5.3 optics test, question 7. We're going to have a go at explaining and doing question 7 because it's causing quite a bit of problems. Now, the key to understanding this question is to read the information in the question really carefully. I know it sounds obvious, but I had to read it a few times. So I'm going to read it again. Smartphones have built-in cameras. This is the key sentence. A lens on one side of the smartphone is used to form an image on sensors on the opposite side. So I'm going to make a quick sketch. So if we imagine our phone sort of side on, so our phones like so, we've got phone side on, your camera's usually sort of at the top, so there's a lens on one side, and on the other side are sensors. A smartphone camera is able to form clear images. Remember, the image is going to be formed on the sensors. Sensors are like the digital version of a screen. Of objects at distances from the camera between 4.5 centimeters and infinity. So if I'm trying to draw this to sort of scale, 4.5 centimeters away, from here sort of onwards, they can produce a clear image. So that basically means from here and further away, the lens will be able to focus the rays of light on the sensors. So let's just mark that. So that's a distance of 4.5 centimeters. Sorry. Now, smartphones, I've estimated that it's about a centimeter across, like so. So now what we've got to draw is the ray diagram. So let's take let's do it on the diagram, and then I'm going to draw it neatly below. So what we've got is, let's say we've got, actually I changed my mind, let's just do it, I can't decide. Let's do it on here, so it's not too confused. Let's draw the principal axes in like so, with a dotted line. Let's draw the object. So I'm just going to use an arrow to represent the object. The reason I'm using an arrow is because it's easy to identify what the top and the bottom of the object is. We've got the converging lens. So I'm going to just make this converging lens look like a converging lens by putting the arrows top and bottom. And we know that if it's 4 centimeters and beyond, 4.5 centimeters and beyond, then the lens is able to focus the rays of light on the sensors. So this is where it gets a little bit challenging. This isn't an easy question. You have your first ray of light is always drawn parallel to the principal axes, like so. So that's ray 1. Now, if we knew where the focal point was, we'd be able to continue that ray onwards through the focal point. But I don't know where the focal point is at the moment. So I'm going to draw ray 2. Now, ray 2 goes through the center of the lens always, and there's no change in direction, so it's a straight line. So there's ray 2. Now, because I know from the question that if the object is 4.5 centimeters or more away from the lens, that the rays of light can be focused on the sensors, I can now draw in the end of ray 1 like so. Now, the image that's formed, this is where it's not that easy to see, is an arrow here, like so. Now, in this question, 7a, there is one mark. I'll just get my red pen. Just give me a second. I haven't used my red pen in a while. So ray 1 is your first mark. Drawing ray 2 in is your second. Drawing, what's the third mark for? Where they cross over. Now you could draw those rays of light beyond, I just haven't because it's a sort of end of the phone. But where they cross over and drawing the image is your third mark. And your fourth mark is for the image being, got to meet 3 bits of criteria. It's got to be real, Now I know this one is real because it's on the opposite side of the lens from the object. Okay, so this is your object and this is your image. So it's on the opposite side of the lens from the object, so that means it's real. It's got to be inverted, and I can see this one is inverted because it's on the opposite side of the principal axis from the object. Okay, so the image is below the principal axis, the object is above, so that means it's inverted. And lastly, it's got to be diminished, which means smaller, and I can clearly see that this arrow is so small I'm really struggling to draw it in. Sorry, it's not that clear. It's smaller than the arrow to represent the object. So that would be getting the fourth mark, so on the lens, right? So we're clearly told we're working with 4.5 centimeters away. Now, what I suggest you work with or you review is this page in the textbook, page 180, this section here. Okay, this is what this is all to do with. So if you're confused, 180 to begin with, image calculations. I think there was a video on the lesson I put together as well. So what we need to remember is that 1 over the object distance is equal to, plus 1 over the image distance is equal to 1 over the focal length. Now I know it doesn't ask us to calculate the focal length, but 1 over the focal length is equal to the power. So if we work out 1 over the object distance plus 1 over the image distance, we'll work out the power. So we're going to use our the question and the work we did above. So the object distance, here's our object, and it clearly says in part B of the question for an object that is 4.5 centimeters away. So 1 over, now because I'm working out the power, for the power to be in the correct units, we need to have the object distance in meters. So 4.5 centimeters is 0.045 meters. The image distance, this is where we have to take the estimate of the thickness of our smartphone into account. So I already estimated that it was 1 centimeter to draw this diagram. If you hadn't already done that in part B, well, you'd probably be looking at your smartphone and thinking it's around about a centimeter, maybe a bit less. So I'm going to use a centimeter. The mark scheme uses 0.8 of a centimeter, but I'm going to keep it as a centimeter. So 1 centimeter is 0.01 of a meter. And if I do that calculation, I get an answer of, so that's going to equal P. Let's do the whole thing actually. So 1 over 0.045 is 22.2. 1 over 0.01 is 100. Should really have them all to the same number of decimal places. And therefore that will give us a power of 122.2 diopters. Okay, and that is how you would do question part B. So your mark scheme allows you, let me just get that up, it's 1 mark for using this formula. It's 1 mark for estimating, it's 1 mark for realizing that if you've worked out 1 over the focal length, that's equal to P. 1 mark if you calculate the power within an acceptable range, which this one is. Okay, so that would give you 3 out of 3.